Hello boys and girls, welcome to Science and Daily Life. I am Sir Zamin.
And I am Miss Freeman.
How are you doing today? I trust that you are doing well and you're fully prepared for today's class. Can you recall what we would have done in our previous lesson? Yes, we would have identified parts of a simple circuit. We differentiated between conductors and insulators. And lastly, we look at circuit symbols. Today we will continue along the topic electricity.
Now, boys and girls, our objective for today is to discuss electrical quantity. Can you recall, boys and girls, in our previous lessons we talked about atoms? Now, we looked at the atoms of elements, and we described the atom as considering to have protons and neutrons in the nucleus, and negative electrons moving around it. Well, it is this free electron which are responsible for the conduction of electricity in metals.
So students, we can think of an electric current in a metal wire as a movement or flow of the electrons. The electrons are present in the atoms all the time, but to get an electric current, we have to make them move. One way of doing this is to use a cell or battery.
Very well, sir. Now, the electron flows around the circuit through the wires. Here, boys and girls, you can see a diagram of a simple circuit. Now, the switch and the bulb is also a part of that circuit. So the electron will flow right around the wires, the switch, and the bulb. The cell acts like a pump and forces the electrons around. They leave the negative end of the cell and travel through the circuit and come back to the positive end of the cell. Let's take a look at that diagram again, boys and girls. You can see we have a simple circuit. It has a cell, a switch, and a bulb. We're simply saying that the electrons will leave the negative end of that cell, travel around the circuit to the positive end of that cell. It must be noted, boys and girls, that the cell does not produce the electrons. They are within the metal wire.
Students, I do trust that from our previous lesson when we taught you how to identify parts of a simple circuit, that you have taken the opportunity to build your mini circuit at home. So when scientists first investigated electric current, they thought it was the flow of positive charges repelled from the positive plate, and this was referred to as conventional current. When the electron was discovered in 1895, it was realized that the guess had been wrong. Due to this old idea, the conventional current on current is still marked today as flowing from the positive of the cell to the negative. But the electron flow is really negative charges flowing the opposite way.
Now, boys and girls, like Sir rightfully said, conventional current basically talks about the flow of, current from positive to negative. But in actuality or in reality, it is the flow of electrons from the negative to the positive. Now, in order for us to measure electric current, we use an instrument called an ammeter, and it has a symbol capital letter A. The unit in which we measure current is called an ampere, and it's represented with a capital letter A as well. It was named after a famous scientist, Ampere. Since an ammeter measures the current flowing through a circuit, it is always connected in series with the other components. An ammeter has two terminals, one marked positive and the other negative. The positive terminal of the ammeter must be connected to the positive terminal of the battery. Now, boys and girls, let us take a look at a demonstration of measuring current using an ammeter.
Okay, students, let's dive straight into our activity. Now, in order to do this, we need to set up a simple circuit And as Miss said, here we have an ammeter. The ammeter has a positive side as well as a negative side, and it's clearly marked. As you can see, the symbol for the ammeter is A. And A is also the symbol for the unit, which is ampere. And as Miss would have said, the ammeter is connected in series to our circuit. So let's do that connection. So I'm just going to break the circuit here because I want to find out the amount of current passing through my bulb. And I'm going to insert my ammeter in series. Remember the negative terminal of the ammeter to the negative terminal of the battery, and the positive terminal of the ammeter to the positive terminal of the battery. All right? So, Miss, you want to help me here, please?
Yes.
So this is called teamwork in the lab, right? Alrighty, so I'm going to connect my circuit, and here I have my bulb lighting, and we can look at the ammeter and see that the needle has moved. That needle there is reading 0.2 amps. So this is telling us that the current flowing through the bulb is actually 0.2 amperes.
Now, boys and girls, we just talked a little bit, or we demonstrated current flowing through a circuit. Let us talk a little bit about voltage or potential difference. We mentioned earlier that the cell acts like a pump and it's driving electrons around the circuit. This is true for all other sources of electricity. However, some sources can do better than others. They have more power or strength behind them. We often refer this power to moving electrons, and it's also called voltage, and it's measured in volts represented with a capital letter V. We can compare the movements of electrons through a wire with the flow of water through a pipe at the bottom of a water tank. Let us make that comparison of voltage to that of water in a tank.
Okay, students, so let us compare voltage to that of a water tank. Now, the reason we're doing this is for you to get a better understanding of how voltage actually operates, okay? Now, the greater the height of water in the tank, the greater will be the pressure of the water through the pipe. Voltage is something like an electric pressure difference, and it is referred to as potential difference, which is abbreviated PD. The electric current, on the other hand, can be compared to the rate of flow through the pipe. The voltage does not flow. It is just an electric potential difference. Now, students, the voltage of an ordinary cell is 1.5 volts, whereas the voltage of a car battery is usually 12 volts. In Guyana, the voltage of the mains is 110 volts and 220 volts.
Now, boys and girls, I know we're talking about voltage, and I know you might get a little, confused because you have heard in your homes your parents would say, oh, the current is 110 or the current is 220. In reality or in actuality, we're talking about the voltage that passes through your home. The voltage that goes through your home or the main is considered to be 110 or 240. Now, let us take a look at the voltage in your home or the mains in comparison to the voltage of a cell or a battery. The simple cells that we have sometimes, our toys that we play with, they would require a 9-volt battery. Let's compare 9 volts to 110 in our home or 220. You can see the major difference there. Hence the reason, boys and girls, we do not play with electricity, or we do not tamper, interfere with electrical appliances in our home.
A typical example, Home Alone, right? Remember
Yes.
what happened to Harry and Marv when they started zing up with that voltage there? That's how dangerous it is, right?
Now, as I'm saying, boys and girls, electricity is very dangerous and it can kill you. So you need to be very careful with that because of that ratio of voltage from the mains to that of your simple cell or battery that we have in our toy cars or in our toys or remote controls and so on. Now, the voltage of a cell, a battery, or any other source of electricity is measured by using an instrument called a voltmeter. The symbol for a voltmeter is represented with the letter or capital letter V. And to find the voltage of a source of electricity, for example, a cell, you simply connect the voltmeter across your simple circuit, and it should be parallel, connecting it to the terminal of the voltmeter marked positive to the end of the source and that marked negative to the other end. So, boys and girls, let us dive into another demonstration of using a voltmeter.
Now, students, as you can see, the voltmeter is similar to that of the ammeter, but look at that. It is denoted with a V, which means that it's a voltmeter. All right, despite they look the same way, this appliance, or this instrument, rather, is being used to measure the voltage. And as Miss said, it is connected in parallel to the appliance, which is completely different from our ammeter. Now, just like the ammeter, the positive terminal of the voltmeter must be connected to the positive terminal of the battery. All right? So I'm just gonna, Miss is gonna help me hold here. You can just hold this with me, Miss. And this to the other end here. All right, so Miss would have hold her connection there, positive to positive, negative to negative. All right, so time to see if, so look at that. As you can see how the voltage is very high. All right, so this shows you that the voltage is about 5 volts. All right. So students, at this level, you are just required to know how to set up the voltmeter and ammeter. As you go on to exploring science and daily life in third form, you will be able to know more about these instruments.
Now, boys and girls, we talked a little bit about current. We talked a little bit about voltage or the potential difference. Let us now talk a little bit about resistance. What do you think is resistance? What does the word resistance mean? Now, boys and girls, resistance is the ability to oppose the flow of an electric current. A resistor is a piece of apparatus put into a circuit for the purpose of opposing the flow of electrons.
Now, the nichrome wire is an example of a resistor, and so is the bulb on the circuit. So again, why do we need resistors? What is the importance of a resistor? Now, we do not want all of the electrons to go into our appliance because it can damage that appliance. Again, as I mentioned to you earlier about the voltmeter and ammeter, the resistor is also something that we will explore more at the grade 9 level, okay?
Now, boys and girls, what I want you to take a look at is just the symbol of a resistor. Here you can see there are 2 symbols that we use to represent a resistor. Now, boys and girls, we talked a lot about electrical quantities today. We talked about current, we talked about voltage, and we talked a little bit on resistance. That would be all for our session today. I do hope you join us for another lesson as we explore more in science in daily life. I am Miss Riemann.
And I am Sir Zamin.
Bye-bye.